Bismillahirrahmanirrahim. Force in uniform circular motion. We have given a sled that is placed on a frictionless ice surface, and the sled is tied to a post through a rope. The length of the rope is given as 5 meters, and once given a push to the sled, it revolves uniformly in a circle around the post, and it makes 5 complete revolutions in 1 minute. And we have to find the force exerted on it by the rope. The sled is moving uniformly around a circle around the post, and sled has some radial acceleration in it, so we will use Newton's second law of motion. First we have to identify the relevant concept. The relevant concept is identified as Newton's second law of motion because the sled has some radial acceleration in it. Next is the target variable, and we have to find the force exerted by the rope on the sled. And next step is setup. So first we will draw a simple sketch. So this is the simple sketch, and next step is to make the free body diagram of the sled. Suppose the sled is at this position, and we will make free body diagram of the sled at this position. First we place a dot for the sled, and there are 3 forces acting on the sled. First is the weight of the sled that is acting in downward direction, and other is the normal reaction acting in upward direction, and the third force is the radial force that is acting toward the center of the circle. As the radial force is acting on the sled, so there is acceleration in the sled. Direction of acceleration is along the direction of the radial force. Next we have to attach set of coordinate axes. We will take the direction of radial force as x-axis and perpendicular to it as y-axis. Next step is to execute. First we will find the time period. As the sled makes 5 revolutions in 1 minute, so its time period is 60 over 5 times 12 seconds. Next we have to find the radial acceleration, and we know that the formula for radial acceleration is equal to 4 pi square r over t square. The value of the radius is given as 5 meter. The length of the rope is 5 meters, so radius is 5, and we have calculated the time period as 12 seconds. By putting the values of r and t, we will get the value of radial acceleration as 1.37 meter per second square. Next we will apply the Newton's second law of motion. Sigma fx is equal to ma radial. Sigma fx means sum of all the forces along x-axis, and there is a single force acting along the x-axis is the radial force F. So F is equal to ma radial. We know that the value of mass is 25 kg, and we have calculated the radial acceleration as 1.37. By putting the value of m and radial acceleration, we will get the value of force exerted by the rope on the sled as 34.3 Newton. Next step is to evaluate. In order to evaluate the value of this force, evaluate the answer, we will adopt another route. First we will find the velocity of the sled, that is velocity of the sled. V is equal to 2 pi r over t. R is the radius that is known, and time period t is known, so we will find the value of velocity. Another formula for calculating the radial acceleration is v square over r. Putting the value of v and putting the value of r, we will find the value of the force. F is equal to ma radial. So again we will get the same answer, that is 34.3 Newton. So our answer is correct. Thank you very much for watching this video.